So 13, 14, 15, doing the sum, difference, and product of two functions. Here, s plus t, I'm adding my functions. Here, s times t, I'm going to multiply them. Here, s minus t, I'm going to subtract them. And I'm going to evaluate it at x equals 4, which we'll get to. So first of all, if I'm going to add, I'm going to take my s function, which is the 3x plus 6. I'm going to add my t function, which is the 4x. Now, since I'm adding, I really didn't need the parentheses, but I put them there because the order is important when you subtract, not necessarily when you add. So I'm going to combine my like terms. 3x plus 4x is 7x, and so I get 7x plus 6, and there's nothing else I can do to simplify that, so that's just going to be my answer. Now, on the next one, I'm going to do the s times the t. So I'm going to take the 3x plus 6 times the 4x. And since I'm multiplying, I end up using my distributive property there. 3x times 4x is 12x squared. 6 times 4x is 24x. I don't have any like terms, so 12x squared plus 24x is going to be my answer. Now on the second one, you can either subtract them first and then put the 4 in, or put the 4 in and subtract them. Just for fun, if I do it this way, s 3x plus 6 minus the 4x. I have to distribute my negative, so I'm going to take 3x plus 6 minus 4x, which gives me negative x plus 6. I'm then going to evaluate that answer at 4. So if I would put a 4 in for my x, I would have negative 4 plus 6, which is 2 for my answer. Now the other thing I could have done is I could have put the 4 into the original expressions. 3 times 4 plus 6 would have given me 12 plus 6, which is 18. Then put the 4 in my other expression. 4 times 4 is 16. Tells me I'm going to subtract those two values. 18 minus 16 is the same 2. So you can see it works either way. I just kind of like to be consistent as how I do the problems. So I usually do the evaluation first, then put the number in and solve it at the end. Not that it makes a difference. So if I look at the next one, I'm doing s plus t. So s is the x to the third plus the t, which is the 3x squared. Now here I don't have any like terms, I really can't do anything, so I just get the x to the third plus the 3x squared, and that's going to be my answer. The next one says to do s minus t. So I'm going to do the x to the third, I'm going to minus the 3x squared. And I use the parentheses because on the negative, if that was a binomial, you'd have to distribute it out, and you want to make sure you get your signs changed. On this one, it's not going to make much difference. I just get x to the third minus 3x squared. They're not like terms, so that's just going to be my answer. On the last one, I'm going to do s times t. So I'm going to take my x to the third times my 3x squared, which would give me 3x to the 5th power. I'm then going to evaluate that at negative 1. So 3 times negative 1 to the 5th. Well, negative 1 to the 5th is still negative 1. Negative 1 times 3 gives me negative 3 for my answer. I got to remember, follow my order of operations, so do exponents then multiply. Same thing here. I could have put the negative 1 in each of these separately and then multiplied my answers. Negative 1 cubed is negative 1. 3 times negative 1 squared. Negative 1 squared is a positive 1. 1 times 3 is 3. And then multiplied my answers. Negative 1 times 3 gave me that same answer of negative 3. So if you want to double check, you can do it both ways. Number 15. I'm going to do s times t first. So I'm going to take x plus 5 times my 2x squared. And again, I'm going to have to use my distributive property. So I'm going to get 2x to the third plus 10x to the second. And again, not like terms, so I can't do anything other than distribute it out, multiply it out. The next one tells me I'm going to add x plus 5 plus my 2x squared. Here I don't have any like terms that I can combine. However, I could rearrange the order so it was in the best order. So 2x squared plus x plus 5. Just going to end up being my answer on that one. For the s minus t, I'm going to take x plus 5 and I'm going to subtract my 2x squared. Again, I really don't need the parentheses since there's only one term there, but if it were a binomial or a trinomial, I need for sure to use the parentheses, so I'm going to put them there. Putting this in the best order, I'd have negative 2x squared plus x plus 5. But this one is the one we're going to evaluate at 4. So negative 2 times 4 squared plus 4 plus 5. 4 squared is 16. Negative 2 times 16 is negative 32. Plus 4 plus 5. So negative 32 plus 9 gives me negative 23 for my answer. And again, if I wanted to double check that, I could put those in here. 4 plus 5 is 9. 2 times 4 squared would be 16 times 2, which is 32. 9 minus 32 gives me the same number I got down there, so I know that I did it correctly.